Prove by contradiction that the cube root of 2 is irrational. 5 marks. This is a contradiction job. We assume the opposite and let the algebra break it. You can't attack irrational head-on. It's a claim about what the number isn't, and there's nothing to grab. So suppose the opposite. Suppose the cube root of 2 is rational. Then we could write it as a over b, with a and b whole numbers. And one more thing. We insist the fraction is fully cancelled. Lowest terms, no common factor at all. That line is doing more work than it looks like. Keep an eye on it. The cube root is the awkward part, so cube both sides. That gives 2 equals a cubed over b cubed. Multiply up by b cubed, and there it is. A cubed equals 2b cubed. The whole claim, rewritten in whole numbers, and whole numbers are where we can start an argument about even and odd. Now stare at that 2b cubed for a second. It's 2 times a whole number, and 2 times a whole number is even. So a cubed is even. Careful though, we need a itself, not a cubed. Here's the trick. A is a whole number, so there are only 2 options. Either a is even or a is odd. Suppose it were odd. Every odd number is 2k plus 1. Cube that, and every piece of the expansion picks up a factor of 2, except the plus 1 hanging on the end. So an odd a would give an odd cube. But we've just shown a cubed is even. That can't happen, so a isn't odd. Only one option left. A is even. Write it as 2k. Feed that back in. If a is 2k, then a cubed is 8k cubed. So 8k cubed equals 2b cubed, and dividing through by 2, b cubed equals 4k cubed. That's 2 times 2k cubed. Even again. Same argument as before, just quicker. B cubed is even, so B is even too. So A is even and B is even. They share a factor of 2. Maybe you're thinking, fine, cancel it and carry on. But look back at the assumption. We said the fraction was in lowest terms. Fully cancelled, nothing left to take out. That was the deal. Both of these can't stand at once. So the assumption breaks. The cube root of 2 was never a over b at all. And say the ending properly, because this is where marks get thrown away. The assumption was false, so the cube root of 2 is irrational. That's proof by contradiction. Assume the opposite, be honest with the algebra, and the impossible ending does the rest. The same skeleton proves root 2 irrational, and that there are infinitely many primes. One check before you move on. Your proof has to use the lowest terms line. If it never came up again, the ending proved nothing.